When you push a dough using a rolling pin, is there a force applied? If your answer is yes, then you got it right. How about when two teams play tug of war? Do you think forces are acting on the rope? If you answered yes, you are absolutely correct. How about when the books are placed on top of the table? Is there still a force involved, even if the books are not moving? Some of you might say no, while others may say yes. But the correct answer here is yes. Even if the books are not moving, forces are still acting on them. In all these situations, forces are present. But did you notice something? Sometimes objects move, and sometimes they do not. But why do you think this happens? So today, we will learn that this depends on whether the forces acting on an object are balanced or unbalanced. But before we delve deeper onto the differences between balanced and unbalanced forces, let's first review what force is. To check how well you understand about this concept, we will have a short activity. Please do a thumbs up if you think the following statements are correct, and thumbs down if you think the statements are false. So let's begin. Number one, force is a push or a pull that causes changes in the motion of an object. What do you think is the answer? So this statement is correct. So the answer is thumbs up. Now take a look at these two cute GIFs. In the first GIF that I have presented, you can see a man pushing a cart. At first, the cart is stationary or not moving at all. When the man applies a pushing force, the cart starts to move, thereby changing the motion of the object, which is the cart. In the second GIF, the donkey pulls the rat as well as the boy. The donkey applies a pulling force which causes a change in motion of both the rat and the boy. So these examples show that a force, whether a push or a pull, can make an object move or change its motion. Now let's move on to number two. The unit for force is Newton. Thumbs up or thumbs down? If your answer is thumbs up, congratulations, you got it right. Now let's think, why do you think this answer is correct? Remember guys, the Newton, or symbolized by capital letter N, is the standard unit used to measure force. And it is named after Sir Isaac Newton, a scientist who studied motion and forces. We use newtons or capital letter N to describe how strong a push or a pull is. For example, a small push coming from a puppy pushing a cart here has a smaller force. For example, the force applied by this puppy is 5 Newton, while a girl here pushing this heavy box exerts a stronger push, and that requires a larger force, such as, for example, 100 Newton. So remember guys, whenever we measure force in science, we use the unit Newton or capital letter N. Remember, unit for force is Newton. Now let's proceed to number three. A force has a direction. What's your answer? Thumbs up or thumbs down? If you answered thumbs up, you were right again. Great job. So let's know why this is the answer. Remember, guys, a force is not just about how strong it is, but also about which way it is applied. For example, when this man pushed a door forward, the force is directed forward. And when this man pull it back or pull the door back, the force is directed backwards. So, the direction of the force affects how an object moves. If you change the direction of the force, you can also change the direction of the object's motion. Again, when you try to push something, it is directed away from you. And if you try to pull something, the object would be directed towards you who exerts that force or effort. So this is why direction is very important when we study forces, especially when we talk about balanced and unbalanced forces. Now let's proceed to number 4, the last item in this activity. A force is always balanced. Think carefully about what we have discussed so far. So what's your answer? Thumbs up or thumbs down? If your answer is thumbs down, you are absolutely right. So, why is this answer correct? Remember, guys, a force is not always balanced. Forces can either be balanced or unbalanced, and the difference affects how objects move. And let's take a closer look at these two types of forces, balanced and unbalanced force. Let's begin with balanced force. So balanced forces occur or happen when two or more forces acting on an object are equal in strength and opposite in direction. So when forces are balanced, the object does not change its motion. This means that the object either stays still, maghambal kita, stay still, another term for it is stationary, or it is not moving. Or, um, aside from that, the object continues moving at the same speed in the same direction. So that is an example of a balanced force. So net force here is also zero. So remember, when forces are equal in opposite direction, they cancel each other out. That's the reason why the net force becomes zero, and thus no change in motion, or the object remains still, stationary, or not moving. So let's have here a closer look at some examples of balanced force. One good example of a balanced force is a tug of war with equal strengths. For example, both teams here pull on the rope with equal strength of 300 Newton each, but in opposite directions. So the force applied by Team A is 300 Newton on the left, while Team B applies 300 Newton on the right. And because the forces are equal in size and opposite in direction, they cancel each other's out. This means that the net force here is zero, because 300 Newton minus 300 Newton for another team is equal to 0 Newton. So since the rope here does not move, there's no winner for this particular game. Okay? Remember, guys, forces always occur in pairs. Team A here, pull, is matched by Team A's pull in the opposite direction. Forces here occurring pull and pull from both teams. All right? Another example is pushing a wall. When you push a wall, you apply a force forward, right? And at the same time, the wall also pushes back with an equal force in opposite direction. So these forces cancel each other out, so the wall does not move at all. So 150 newtons applied by the man is also taking place. 150 newtons applied by the wall towards the man. They cancel each other out. 150 newton minus 150 newton, then the net force is equal to 0. Thus, no motion happens. Again, notice the pair of forces. The man push and the wall's reaction pushes in opposite direction. Another example is a book resting on a table. Gravity applies a downward force on the book, so that signifies its weight. And the table provides an equal upward force called a normal force. And these forces are equal and opposite, so the book remains at rest. Again, the reason behind this is both forces are equal, 15 Newton, but they occur in opposite direction. So to get the net force, 15 Newton minus 15 Newton, that is 0 Newton. So the object remains still or not moving. Another example of forces occurring in pairs. Pull of gravity going downward and the push of the table going upward. On the other hand, when forces are not equal, they are called unbalanced forces. Unbalanced force cause a change in motion, or it causes the object to move. This means that the object can start moving, can stop, speed up, slow down, or change in direction. So why does this happen? Um, Remember, in balance force, the equal forces occurring on opposite direction cancels each of the forces out. That's the reason why the net force is 0. But in an unbalanced force, um, one force is greater than the other. So the net force here is non-zero, meaning higher than 0. It could be 1, 2, 300, 500, and so on and so forth Newton. Again, but not 0 at all. So since the net force is no longer 0, the object moves in the direction with a greater force. Now, to understand this deeper as to how it is different from a balanced force, let's have another example. Still about the tug of war, but you would notice that they have unequal strength. So Team A on the left pulls with 400 Newton, while Team B pulls with 300 Newton in the opposite direction. The forces do not cancel because Team A is stronger. So to solve for net force, the higher force, which is 400 Newton, minus 300 Newton on the opposite side equals 100 Newton. And as mentioned earlier, the object will move in the direction with greater force. In this example, Team A on the left has greater force, so the rope or the other team will move towards the left side where the Team A is there. So in this particular game, Team A or the team on the left side, which has greater force, wins in this particular game because we have here net force of 100 Newton more than 0. So this indicates that the object will move because there is an unbalanced force. So remember, guys, even though forces occur in pairs, if they are unequal, it will result to motion or movement. Another example of unbalanced force is when you push a door, you apply a forward force. The door offers resistance, but your push is stronger than the door's resistance, meaning your force is greater than the force applied by that door. So the net force here would be not equal to zero because unequal ang aton nga forces. And that's the reason why the door will be pushed forward and it will move. Again, net force is not zero because although the door offers a resistant force, but your push is stronger or greater than the resistance. And remember, the object moves in the direction with more force. And since you pushed it forward, your force is greater, thus the door will also move forward, going to the direction with greater force. All right. Now let's proceed to another example. Another example are books falling from a table. Remember, guys, gravity applies a downward force in the book. Again, gravity applies a downward force of the book. Going downwards. That's the force of gravity because gravity always pulls everything back to the center of the earth. And once the book is pushed or falls, there is no opposing upward force stronger enough to cancel the gravity. So the net force here is the weight of the book downwards. So it accelerates or it moves towards the ground. So since it is moving, falling from the table, that signifies that there's an unbalanced force, and that unbalanced force comes from the weight of the book downwards with no opposing upward force strong enough to cancel the force of gravity. So greater gyapon ang force of gravity going downwards. That's the reason why the books fall from the table. There's motion, there's movement. So interestingly, there's an unbalanced force in there. So remember, guys, even though gravity is always paired with a reaction force, in this case, the forces are unbalanced, causing motion. Now, let's try to measure your understanding. You identify if the given situation showcases balanced force or unbalanced force. Let's begin with the first one. So these two men pushing the stone in opposite direction. Man on the left applies 100 Newton force to the right, whereas the man on the other side also applies the same amount of force, which is 100 Newton, towards the left side. So, is there a balanced or unbalanced force? If your answer is balanced force, then you got it right. There's a balanced force acting upon this particular situation. So how do we know that the forces are balanced? So the net force here is zero because they cancel each other out. Remember, they have equal forces, 100 Newton, and they move in opposite direction. 100 Newton minus 100 Newton, that's 0 Newton. 0 Newton indicates that there is a balanced force. Thereby, it is expected that this stone or whatever it is that they're pushing in opposite direction will stay still or not move at all. Another example is this one. Unlike the other example, this one, both of them have a combined force. They try to move this heavy stone or boulder on towards the left side, and their combined force is 200 newtons. Notice on the other side, there's no force seen here. So my question here, do you think this situation showcases balanced force or unbalanced force? If your answer is unbalanced force, then you are right. Ma'am, why is there an unbalanced force here? Now, remember, darlings, in this side, they applied 200 Newton force. On the other side, although there's no one pushing in there, there's also a force which is called friction, right? A friction force that opposes that force applied by these two men. Although it's negligible, there might be, for example lang niya, hypothetical, 20 Newton force of friction applied by the surface where this stone or heavy object is situated. So although there is a friction or there's a force on the opposite direction, still the force applied by these two men, which is 200 Newton, is greater than the force being applied by the surface. So there is still a net force, let's say for example, 180 Newton. So that's the reason why it would be expected that this particular heavy thing that these two men are pushing would move towards the direction where the greater force is situated, and that is towards the left side. So, I hope this is clear to everyone. Another example is this one. These two people trying to push this cart full of candies. One, the blue one, pulls this cart with 60 Newton force, whereas the other one here, bigger one, color red, tries to pull this cart with 150 Newton. So is there a balanced or unbalanced force in here? Of course, very easy. There's an unbalanced force because if you notice, unequal ang forces in both sides. The other side is 60 Newton while the other one is 150 Newton. So where do you think will this cart go? Of course, it will go to the direction where the greater force is being applied, and that is towards the right side. So what is the net force here? 150 Newton, the greater force, minus 60 Newton, that is 90 Newtons to the right. Okay? So it is expected that this cart full of candies will move towards the direction where the greater force is, and that is towards the right side. Now, if you notice, even in the previous slides, there are arrows symbolized by the direction of the force. And you would know that the forces are equal or unequal depending on the length or kalabaon sang arrow. Shorter arrows means smaller force, whereas greater arrows or longer arrows means greater force. So remember that. And last example is this one. There are three people here pulling this rope, and the other one, a heavy one, greater force, pulls this rope to the other side. But even if they vary in number, but the forces applied by both teams are both 330 Newton. So is there a balanced or unbalanced force? Of course, there are balanced forces in here because again, the forces exerted by both sides are equal, the same, 330 newtons. So 330 newtons minus 330 newtons, that's equal to 0 newton. And since the net force is 0 newton, it is expected that there will be no motion, no movement, and the rope will stay still. So no winner will there will be no winner for a short time. But remember, syempre, kung naluya na ang piyak nga team, naga-lesser ang force nila. So there's a tendency that the other side would win later on. But instantaneously, kung equal ang force, both sides, of course, stationary expected, hindi na siya maghulag. So in summary, balanced forces are equal in strength and opposite in direction. So they cancel each other out, resulting in no change in motion. Unbalanced forces are unequal, producing a net force that causes the object to move, speed up, slow down, or change in direction. And in every case, forces always occur in pairs, but it is the balance or imbalance of these forces that determines whether motion changes. So that's it for today's lesson on balance and unbalanced forces. Remember, forces always come in pairs, but when they are balanced, nothing changes, nothing moves, or it will continuously move on the same speed and same direction. And when they are unbalanced, motion happens. There is a change in motion because of unbalanced force. So, darlings, keep observing the world around you. Every push, pull, or even a stationary object is a chance to see these forces in action. Thank you for watching and keep exploring the exciting world of physics.